So hello everyone, in this video we will solve another LeetCode question, that is climbing stairs. So you are climbing a staircase and it takes n steps to reach the top, and each time you can either climb 1 or 2 steps at a time, and you need to find out in how many distinct ways you can climb to the top. So let us understand this question with the help of this second example and try to derive solution out of it. So this is the example that they have given, where n is equal to 3 and the total number of distinct ways is 3. So let us see how we can get this 3. So this is like in this question they are saying that you have n levels. So this is level 1, this is level 2 and this is level 3 and this is the top. You need to reach the top and you need to determine in how many ways you can reach the top. So initially we will be standing at I equal to 0. Let's say we are climbing the stairs with the help of I pointer. So let's say like initially we will be at I equal to 0. So what can we do to reach the top? So they have also given that condition that we can either make 1 jump or we can make 2 jump. So what does that mean? That if we are currently at I equal to 0, so either we can move to 1 or we can move to 2. So these are the two possible scenarios that they have given. So let us see how we can get this answer as 3 with this example test case. So initially we are at 0. So let's say one way is that we reach to 1, then we reach to 2 and then we reach to 3. So by taking 1 steps at a time, we can reach the top. So there is one possible way. The other possible way can be, let's say we reach to 1, then we reach to 3. So this can be another way. So let me write down all the ways. So first way can be we can take 1 jump. The other can be we can take 1 jump first and then second jump. The third way can be we can directly jump to 2 and then take 1 jump to reach the 3. So the third case can be 2 plus 1. So in the all three ways we are reaching the top as 3. So that's why the answer is 3. So if you see this question carefully and you see the constraints of the problem, let me show you. The constraints are n equal to 45. That means n can be as max as 45. So in this question we need to find the total number of distinct ways. So we can try out all possible ways because the constraints are very low. So we can try to think of recursion, but recursion will give us the time limit exceeded error. Now why? Because we have here two conditions. Either we can take 1 jump or we can take 2 jump. So we are in each case taking 2 possibilities and our n can be as max as to 45. So if we try out all possibilities, in the worst case our time complexity will become 2 raised to power 45 and that will give us time limit exceeded error. So recursion will definitely fail here. So what we can do is we can memorize this solution and we can use a dynamic programming. So we will use a DP. So what we can do is we will initialize an I pointer initially to 0 and we can check all the possible scenarios by going to 1 jump or going to 2 jump, and in the end we will sum all the possible number of ways which we get from 1 jump and 2 jump. Now what will be the base case? So let us see the base case now. So one base case is for sure that if our I is equal to n. So if our I has reached n, that means we have found one way. So we need to return 1. So this is one possible way to reach the top of the stairs. Now what can be the other base case? Now let's say in this example itself, if you are at like this is first, second and third, if you are standing at 2 and you try to take 2 jumps, so I equal to 2 plus you did 2 jumps, so your I will become 4, that is greater than 3. So we don't want this. We need to stop somewhere so that it can't go any further, because we know we can't take any backward jump. So there is no point in going beyond n. So whenever our I is greater than n, we will return from there. And what we will return? Return 0, because from there we don't have any possible way to reach the n because we have already exceeded this limit. So these are the two possible base cases, and we will have two conditions like we normally see in the take not take condition similarly in this way we have either we can take one jump or two jump. So what we can do is we will write one solve function which will do recursion for us, and one time we can increment I by 1, and by calling the recursion again we can like increment I by 2 for the second time or for the second jump, and in the end whatever we are getting number of steps from these two, we will sum it up and store it in our DP table. So this was it. And yeah, one more thing. So what will be the states of DP? We discussed the transition, we discussed the base case. So what will be the states of DP? So the states of DP depends on the number of changing parameters. So what are the number of changing parameters? So we are iterating with the help of I and we are going till the n. So only changing parameter is I. So if there is only one changing parameter, that means only one DP state is required for our DP solution to work. So there will be one state for this DP, and the transition and base case we have already discussed. So let us write the code now and understand in more better way. So first we will create a vector of int DP. We have created a 1D DP. So the number of the size of the DP will be n plus 1, because at max we can reach up to n. So it starts from 0 based indexing, so we need to add one extra size to that so that we can reach the nth state, and we are initializing it with -1. Then we will write the solve function which will give us all the possible ways in which we can reach the top, and in that we will pass first n, then the iterator from which we are moving, that is I. So initially it will be 0, and we will also give the DP table. Now we'll write the solve function. So int n, int I, and vector of int and DP. So these are the three parameters. So what was the base cases? So if our I is greater than n, so we don't want this case and we need to return from there. So we will return 0, because there can be no possible way by which we can now reach to nth state, because we have already we have already passed n and there is no way that we can move backward. So we will return 0. What is the second base case? So if our I is equal to n, that means we reach the top. So that means this is one possible way that we have generated. So we will return 1. Now the DP part. So if our DP of I is not equal to -1, that means we have the overlapping sub problem. So we will return that DP of I. Otherwise what we will do, we have two possible options, OP1 and OP2. So in the first operation what we are doing, so we are taking one jump at a time, and in the second operation what we are doing, we are taking two jump at a time. So we'll increment I by 2 and the rest all parameters remain same, and in the end what we need to return, the total number of ways that we get from this operation 1 and operation 2. But this is not the end, we need to store it in our DP table also. So we will store it in our DP table for overlapping sub problems. So this was about the code. Let us see if this works fine on sample test case or not. So yeah, it works fine. Let us submit it. So yeah, our code got accepted. Hope you learned from this video. Thank you.